My name is Bill Swantner. I am a Texas A&M University AgriLife Extension volunteer master gardener. Texas A&M is the land-grant university for the state of Texas, and it is the organization, the university, that sponsors the Texas Master Gardener Association. They provide our initial training and our additional trainings to keep our certification. Part 1 looked at the San Antonio water system and our sources of water, and how the San Antonio water system gets us absolutely every molecule of water that they can. And this part 2 out of 2 takes a look at what can we do now. Now the sauce has done their part. What exactly is our part? What we can do is we can rethink how we use water. And that goes to soil, plants, rain harvesting, and drip irrigation. This picture was taken in March of 2023. We had 10 inches of rain by the end of March. We'd had 3 inches of rain the previous weekend. It was raining when I took this picture, and you can see the sprinklers were on. We need to rethink water. We did not need to even begin watering our lawns in March. And we need to, just, in cases like this, find the off switch, and you don't need to run the sprinkler system. So part of our soil issue is that in the north side of San Antonio is that it's thin. When it's thin, such as you see these rocks here, the water is going to run off. We're going to lose it into the storm sewers, and it's not going to seep back into the ground. It's not going to seep back into the aquifer. All over San Antonio, we have a high clay content, and clay content means that the water is going to be absorbed very slowly into the ground. So in a 1-inch rain, we may actually only get 1/4 of an inch of moisture into the soil because clay absorbs so slowly. Every molecule of clay wants to absorb water. In sand, the molecules of sand, the sand grain, they don't absorb water. They just let it run on through. But in clay, every clay particle wants to absorb water, and so it filters through very slowly. And then it has little organic content. The significance of that is organic content feeds the microbes in the soil, and the microbes in the soil changes the texture of the soil, changes the structure of the soil, and organic material in the soil helps the soil to use the water more efficiently. This is the Edwards Plateau. This is about Highway 90, give or take. Come along San Antonio, up I-35 to New Braunfels, San Marcos, Austin, on our way to Dallas. This is a very thin soil, and we need to really get about 6 to 8 inches of soil there. So that means bringing in amended soil, not the native soil, but just bringing in amended soil, or growing in raised beds. That is more water efficient. If we live right in here is a smectite clay soil that really needs to be amended with compost. In this area up in here, this is a very highly illite clay soil. Again, it just absorbs water. This area in here with smectite, when it gets wet, it swells up tremendously. And when it dries out, it shrinks tremendously, which creates some of the foundation issues that we run in our house and our buildings. And it creates problems for road fixtures. So, you know, they just fixed the road a couple days ago or a couple weeks ago, and why is it behaving the way it is? Why is it broken again? Because of the clay soil underneath the roads in San Antonio. So we need to make the soil thicker in the Edwards Plateau. This soil along the line here and south of San Antonio, we need to add compost to, or just use raised beds. As I said, most of Bexar County has heavy clay soil, and as I said, it just absorbs very slowly. Here is some clay soil from my backyard, and you can see how the clods are in here. And I'm trying to grow the St. Augustine root system through this. This absorbs water extremely slowly. It encourages runoff. And if we have chemicals, herbicides, pesticides, insecticides, fertilizers on here, and it's right before rain, it's all going to wash away. One thing you do not do before heavy rain is put anything on your lawn, because it's just going to wash out down, end up in our sewer systems, into the streams and rivers downstream, which is creating some ecological issues. And as I just said, if this is a smectite clay-based soil, it's going to rain. When it rains, it's going to swell tremendously, and when it dries out, it's going to shrink tremendously, and it creates huge cracks in the lawn, and you wonder where your dog went. It was there a minute ago. This is my backyard and my front yard. We had an inch of rain, and that water in my front yard, because it's well composted. This is just the basic cheap soil that came with the house. And this is no big deal Raleigh St. Augustine that came with the house. We had a 1-inch rain, and that water seeped down 4 inches. This is an area of the yard that is not as composted, and we had that same 1 inch of rain, and you can see this is dry down in here. Maybe the top quarter of an inch has water in it. So that's the difference between composted soil and let's just say native soil, for lack of a better word, but non-composted soil. The composted soil will allow the water to drain because it has affected the structure of the soil. And here there's no compost. The microbes have not been fed, and it's just the top here got moisture and the rest stayed dry. Ideally, our soil should have 5% organic material. We have maybe half an inch. And so this says 2 to 3 times, really 2 times a year, late fall, early spring. Why? Because it's the cooler times of year. It was 102 degrees outside today, and this is not the temperature to be spreading compost. I put this picture here because this is my backyard that I'm renovating. This darker green has had compost added to it. This lighter green, lime green, has not had compost added to it, and you can see the difference in colors. What compost does is compost feeds the microbes in the soil. The microbes eat the compost, and they excrete minerals and nutrients that in a form that the plants can absorb. So here the microbes have been very well fed, and they've been excreting a lot of stuff, and the grass is beautifully green. Here the microbes are a bit on a diet, and so the grass is a different color green. This is my yard. I did this as an experiment. From August 2018 to July 2019, I did not water this yard. This is my front yard. It has the composted soil. I do not use fertilizer. I do not use any herbicides, pesticides, whatever. This is just compost and water. And this is a lawn that's about 30 years old. It's on a slope from here, sloping down to here. So it doesn't have the best water retention. This is just the regular basic Raleigh St. Augustine grass the builder put in 30 years ago, and it does not get pampered. It gets a lot of sun. It gets a lot of shade here and a lot of shade here, but I did not water it specifically or intentionally for this picture. I have watered the last couple of years because last year we had 60 days of 100-degree temperatures, and this year we've had 20 or 21 days of 100-degree. It's showing the stress of the 100-degree temperatures. All right, so we have the correct soil. If you're north of Highway 90, 281, out Bandera Road, 281, out I-10, try to get 4 to 6 inches of soil. San Antonio Water System and Texas A&M did a study back in the 1980s, I believe it was, and they had 2 sets of 2 beds. One, the soil depth was 4 inches, and the other one I think was an undeterminate depth. And they planted identical grasses, and they had a cover that prevented any moisture getting on the grass for 60 days. At the end of 60 days, the 4-inch turf grass couldn't make it. It did not survive. The other turf grass with deeper roots did survive. The important thing, I can't stress enough, is the soil. And I'll be saying that again and again. A well-amended soil does wonders for our water efficiency. So we spent a lot of time getting the correct soil, and so now we need to get the correct plant and put it in the correct location. There's 3 categories of plants: native, well-adapted, superstar. If you want to know what native is, type into your browser Texas native seeds. And there are 3 or 4 or 5 seed companies. 3 of them are in Texas, one of them here in San Antonio. They have Texas seed mixes, or Texas Oklahoma seed mixes, or Southwestern seed mix, and they'll show you a map of where what they call native plants grow. And they'll list it. And I got this off one of the packages. Texas bluebonnet, Indian blanket, black-eyed Susan, coneflower. You can read this. And so these plants, our pollinators know to look for. These plants grow in our heat. They grow in our drought. They grow in our soil. Here are what some native plants look like. Let me get this out of the way. This is an Indian blanket, beautiful yellow with red on the inside. Opposing that, you have the Plains coreopsis, yellow with red on the inside. Black-eyed Susan comes in a variety of configurations. This is simple yellow with the black on the inside. Landsleeve coreopsis, all yellow. The Mexican hat has this beautiful red, orange to yellow. This is a purple coneflower. It also comes in white. It comes in orange. I don't know how well the orange and the white grow down here, but it does come in purple. And so look at all the colors you can get from a native seed mix. There are some that are well adapted. There is the Mexican mint marigold that loves to bloom in the fall. So you have that fall color. This is the Mexican oregano, which hummingbirds absolutely love. Beautiful light purplish lavender flowers. It's a bush. It's a woody plant, so it's not going to freeze back. It'll be like this 12 months a year. This is the Blackfoot daisy, white with a big, beautiful yellow in the middle. This is one plant. They make it to be 2 feet by 2 feet wide. So it's not like you need to plant them every 6 inches. These plants just spread and they reseed. This is a sage or salvia plant. It's just really representative of all salvias. This is an amistad, beautiful, specially cultivated variety of sage. But the Salvia greggii grow here really quite well. They come in pinks and purples and whites, and they tolerate our weather. What I'll call designer salvias, they're a little bit different. This again is the amistad. There's a bunch of, there's a skyscraper maroon, there's a skyscraper orange. My suggestion is that you grow these in pots the first year, because I planted some of these, what I call designer salvias, and they did not survive our heat, or they did not come back after our winters. So buy 1 or 2 of them, grow 1 in pot, put 1 out in the yard, and see how it happens. The designer ones, there's no guarantee what's going to happen. But some of these, which I'll get to in a minute, like Texas Superstar, the Mystic Leaf Spires does quite well. So let's take a look at Texas Superstars. Go to this website. That's all you need to know. Go to the Texas Superstar website, texassuperstar.com, and if they will take you through any number of plants. They have annuals, they have perennials, they have perennials, they have woody shrubs. They have trees, they have fruit trees, they have vegetables, they have herbs. If you can't find what you're looking for here, I think you're just looking too hard. And so here are some Texas Superstars. This is a columbine, loves the shade, loves spring. So underneath your oak trees in February, March, this will bloom. This is a Moy hibiscus. Across, this is about 8 to 10 inches. Beautiful blooming plant. These blooms only last 1 day. So if this is the plant that you want to plant, understand there'll be 1 day, cut them off the next day. But sometimes, it may bloom for 2 or 3 weeks in a row, and it may give you 5 or 6 blooms at a time. It's absolutely magnificent. Crossvine tangerine. This is in the Texas Superstar, they call this the Mary Mum. In the nurseries, it'll be called the Tashan African Gold. It's called the Tashan or African Marigold. And they love this time of year. This heat, this drought, these things just grow like crazy. They come in orange and they come in yellow. These are the 3 sources for the plants. These plants will grow here. They're used to our soil, they're used to our heat, they're used to our water. So we've got our soil well amended, and now you have a choice of native, well adapted, and Texas Superstar. So you are set and ready to go. Now we need to water these things. Rainwater harvesting is as simple as a collection barrel at the end of a gutter. or you can build a rain garden. So let's start off with a rain garden. This is my rain garden in the back of my yard. A little bit of history. This is a slope that goes down like this from the top of the yard. Down here is about 4 feet. This has served a couple purposes. Before we moved into actually a couple nights before we moved into the house 20, 30 years ago, we had a massive rainstorm, and all the bare soil here flowed downstream and knocked this fence over, and the builder really had quite a mess on their hands. So the fence acts as a berm, but what I did was I put a berm here. Well, let me back up. The fence acts as a berm, and so what happened was this area was St. Augustine, a compacted soil, and it really turned into a swamp, and it was just a mess out there for the longest time. So I decided to turn it into a type of rain garden. Technically, this is not a rain garden. If you go to Texas A&M website and type in, or you type in your browser, Texas A&M University rain gardens, they will take you to a brochure that specifically talks about plants to plant in a rain garden. Technically, this is not a rain garden, but it functions like one. So this is at the end of a 4-foot drop on about a 50-foot yard. I put a berm right here, big rocks and mulch to capture that water here. I took out all the St. Augustine. First, the deepest I could dig was 2 inches. I just couldn't get any deeper than that, and I put expanded shale in here. I read an article by a professor at Texas A&M University that said expanded shale and compost is a great way to break up soil. It's expensive, but it works. So in this area here, I dug this up about 2 inches deep is all I get. I put expanded shale in here and I let it sit. And a couple weeks later, because I was working at the time, I was getting around as best I could, I dug it up again. And this time I get about 3 or 4 inches deep, and I added compost to this entire area. And this area now is a sponge. And on top of that, I put double shredded native mulch, and I'll talk about that in a minute. So now when the water comes here, it's not a swamp. It doesn't knock over this fence. It drains down back into the soil, which happens to be actually a limestone rock. And it filters through the cracks in the limestone rock, and sometimes it filters out onto the street, but some of it goes back into the Edwards. This is double shredded native mulch. Mulch comes in single shredded. There are bark mulches, there are pecan mulches. You want the mulch to absorb water, and bark mulches float away. Back in the 80s, everybody had pine bark mulch, and when it rained, all your neighbors had your pine bark mulch. Pecan shell is a beautiful brown mulch, but again, it's a pecan shell. It does not absorb water, it floats away. Double shredded breaks open the limbs and the sticks so they're more absorbent, and so they help to absorb water. Native means that it is made out of stuff that grows here. I don't need pine bark needles in my yard because I don't grow those plants. I'm growing native, well-adapted plants and Texas Superstar plants. This is not East Texas. So I want this native mulch to be ground cedar elms. I want it to be ground live oak, red oak, bur oak trees. This is a lacy oak. This is a cedar. This is a maple tree right here. That is what this area is used to. So double shredded makes it more absorbent. Native provides the nutrients and the minerals that the plants here need. So this is a rain garden. The water comes down here. It sits here. It soaks in. I do have some pots in here. But there's some inland sea oats. That is a rain garden plant. But some of these in here are some very nice salvias. Let's talk about rain capture. Rain capture is when we catch rain from the sky and we hold it somehow in a cistern. Remember I showed you we can hold it in a rain garden or we can hold it in a cistern. Well, how much rain can we actually capture? This is my roof. It's about 20 feet wide and about 20 feet deep right here. And so there's some real simple math. Even I can do this. You multiply 20 by 20, 400. You multiply that times 0.6, and roughly speaking, in a 1-inch rain, here's the math, I should be able to capture 240 gallons of water. So rain capture is a great way to augment or supplement our watering. There's a couple ways to do the rain capture. This is my deck. It's 10 feet out, 16 feet deep. Let's do the math. 10 times 16 is 160 times 0.6 means in a 1-inch rain, I should be, and this is a rain chain, I should be able to capture 96 gallons of water. Well, this is a 55-gallon container. Well, this happens to be connected by a hose to another 55-gallon container right here, which goes to another 55-gallon container in my propagation greenhouse area that I use and I water by hand. So I have the capacity for 150 gallons, or 165 gallons, and with the 1-inch rain, I can get 96 gallons. So this is very simple. There's a gutter here, rain chain right here, and collect it in the cistern. I connect mine, put your watering pail in there, and water your plants by hand. This is my fancier one. This comes off of the roof. It comes off my 20 by 20 area. It's captured right here by a gutter, which you can't see behind the crepe myrtles. Then I have a first flush. This is what the first flush looks like. This is actually a second first flush. I'll describe that in a minute. The water comes off this roof. It's dirty. So what it does is it goes down a first diverter. And let me just use this one as an example. The water will come off here. The dirty stuff will settle to the bottom. And then the clean water rises to the top and continues on. Well, I have this over here. And when I've unscrewed this, and it's a PVC pipe and I can unscrew it, the water coming out here is just horrendously disgusting. It's dark and it smells sometimes. It's just bad because it's coming off of here and it's been sitting in this tube. Well, I have two first diverter flushes, and I'll tell you, there's two reasons why. One, I had the pipe coming across here. This is 3-inch tubing, and I needed some way to support it. I had a brace here, and I just wasn't comfortable with that. So I thought, well, I'm going to put a tube here to support the bracing, because this is quite a stretch here. And the second reason is I wanted to see how clean that water really was. So it comes off the roof dirty, goes to the first diverter over here. Hopefully it gets it out. So I've checked this, and the water coming out here is amazingly clean. What that tells me is the water going in here is amazingly clean. So the water comes down here into the gutter. The first diverter catches most of the dirty stuff. It continues over here. The second diverter catches the remnants, and it goes into my two cisterns. This is a 250 gallon. This is a 55 gallon container cistern. There you go. This is, again, my 250, my 55, and this shows what the inside of the 55 looks like, and this tells me about how much water I've used in my drip system. This flows into here, and the reason is, I don't know how much water is in here. This is 6 foot tall, and I could get a ladder. I could buy something that'll tell me how high it is, and it's just easier for me to run this water into here, and then as I use my drip irrigation from here, if I use half of it, that's right about 30 gallons, and as I go through that twice, I know to fill this back up. And I also know how much water is in here by how high the water level is here. If there's only so much water here, that's only going to be that high here. So that gives me another indication. This is an overflow. The overflow needs to match the inflow. If you have 3 inches coming in and 2 inches coming out, there's a real good chance of the rains we've had this year, this would have been a disaster. Water would have been flowing out the top. But because this 3-inch drain pipe, I took it down the side and I put it over here, and it flowed down over here, down the yard. So 250 gallons, and I can fill it up with 55 gallons. This is from the Exotic Pet Resort outside of Johnson City. How do they feed their exotic animals out here? Well, it's pretty simple. They just have this shed. It goes at an angle. They collect it off here. They go through this PVC pipe, and they collect it in this cistern, and they can feed they can make sure their animals are hydrated in the middle of this really pretty warm area. So back to mine. Out of the 55-gallon container, it goes to a 40 mesh filter, a 10th horsepower pump, 40 mesh filter, 80 mesh, 100 mesh. All right, so let's talk about this. The water coming out here is going to have some pollutants in it. It's just the nature of stuff. Plus, there's stuff that settles in here. I have this filter. 40 mesh is the size of the hole inside the cylindrical filter. 40 mesh catches the big particles unless the little particles go by. I have this here because when I took the rainwater harvest advanced training from Dr. Dottie Woodson, she gave me the name of a gentleman to contact about setting the system up, and he really recommended a 40 mesh filter, cleaning the water a little bit before it hits the pump. So that's why this filter's here. The water comes out here. It's really pretty clean, but I won't take any chances. It gets cleaned a little bit, hits the 10th horsepower pump, goes around here. Why do I have the second one? Because I had it. So it's either going to sit in the garage collecting dust, or I can put it to use. You don't need the second 41. The 80 is a smaller hole in the cylindrical tube, so it takes out a little bit more pollutants. And then finally a 100 mesh, and that takes away even more pollutants. So between the large, medium size, and small, the water is slowly cleaned out before it goes into the tube. From time to time, I will need to unscrew these tops and clean the metal filter inside, and then put them back in. And this simply shows the 10th horsepower pump. Here's the hose, the drip irrigation hose that it goes into. This is the brown one. The holes are pre-drilled. I think they can be drilled as small as 6 inches, but 12 inches or 18 inches apart. This is pressurized. There are soaker hoses. The problem with soaker hoses is they're not pressurized, which means you plug it in to the hose right off the faucet, and the next foot, maybe 2 feet of hose, of soaker hose, there's a lot of water coming out because it's right at the source. But 25 feet down the garden, there's hardly any water, if any water, coming out because there's no pressure. There's nothing forcing the water to go down 25 feet. Plus, those hoses really can decompose in the sun. These are pre-drilled and they're pressurized, so the hole at 1 foot and the hole at 50 feet had the same amount of pressure. Now, what I found in mine is my pre-drilled holes will give me 1 inch of water every 45 seconds. So if I have that on for 10 minutes, I've gotten over 10 inches of water on that plant. You can get these and pre-drill, and you can get this and drill your own hole, and that's this emitter right here. It's 1 gallon. You can go as high as 5 gallons. Basically, you punch a hole and then push this emitter in here, or you buy a special tool that grabs this right here, and it helps you push it in there. It saves on your thumbs a little bit. And you can space these where you need to. So you may not want a spacing every 12 inches. You may want a spacing every 24 inches, or 120 inches, 128 inches. And you can control how much water is released. You want a 1 gallon per hour? Maybe you want 5 gallons per hour. My 1 gallon per hour will give me 1 inch in 30 seconds. That means in 1 minute, 2 gallons of water. In 10 minutes, I've released 20 gallons of water, 20 inches of water in this one area. If you connect it straight to the faucet of your house, there's the backflow preventer, which I believe is required by law. Splitters, if you have 2 different hose outlets. They put a filter on here. Looks like it's going to be 100, maybe a little higher. Here's a timer so you don't forget it's on. Here's a pressure regulator. The water coming out of the faucet is way, way, way too high for a drip irrigation system. And so this will limit it to 25, maybe 20 or 30, and you'll determine which one you want to buy. And then here's the adapter for the drip irrigation tubing. So here's mine. Here's the black one. And I use this because these are further spaced apart. So I have this one, but then I have this one. So I put in my own emitters. They're 1 gallons. So I know that in 30 seconds, these folks get 1 inch of water. These are more regularly spaced. So I have the brown one. You can see it right here. And I have a little cutoff valve over here that I can turn one on and turn one off. Sprinklers and evaporation. We have to worry about environmental conditions, sprinkler design, and nozzle type. This is probably, I think, it's one of the best sprinklers out, and I'll explain why. I can control the size of the water droplet with this little screw. I'm not a sprinkler guy, so I don't know the fancy terms. This screw, the tighter, the more I push it in, the smaller the droplets are. The more I unscrew it, the larger the droplets are. And this little lever here, if I have it all the way down, I can minimize, maybe keep it to spraying only 3 feet out. If I lift it, it might be able to spray 20 feet out. Here's the thing about sprinklers and droplets. The smaller the droplets, the more it is subject to evaporation. So some of these in-ground systems, they come out these sprays. Those sprays are evaporating more than they're hitting the ground. You want as large a droplet as you can get, preferably not shooting 20 feet across, because the farther it goes, the more it evaporates. And you see these oscillating sprinklers that go like this. They're shooting 15 feet in the air and they have that very small droplet. At the very height, that sprinkler is not really giving you that much water and you're wasting it. We need to rethink how we use water to appreciate the work the soils has done for us. So this is really one of the better sprinklers. Let's go through these 4 right here. Environmental conditions. How effective a sprinkler will be depends on the temperature. If it's 70 degrees outside, it's not going to evaporate so much. At 100, it will. In dry weather, the air is going to suck up the water. If it's very humid, the droplets are going to survive, are going to last longer. Wind speed. In a 10-mile-an-hour wind, a lot of that water is going to be evaporated, which is a challenge for us at night because the San Antonio water system says water from 7 to 11. And from 7 to 11, often we have breezes from the southeast, and they can be pretty strong, and they can just blow our water all over the place. Solar radiation is the intensity of the sun, for lack of a better definition. 90 degrees at noon feels a lot hotter than 96 degrees at 7 o'clock at night, or midnight down here, because the sun's rays are more intense at noon. They're right overhead, and they're beating on you, and that 90 degrees, you're feeling it. But when the sun rays are lower at 96 degrees, the solar radiation is less. So this affects how effective your sprinklers are going to be. I talked about sprinkler design and nozzle type. The larger the droplet, the better. Basically, it's what it comes down to. Water application rate. San Antonio water system has suggests that we do soak and cycle. The reason is because most yards in San Antonio do not have amended soil. If you have amended soil, this doesn't apply to you. But since most people do not, they suggest watering for 15 minutes. Let that water soak in probably to the top 1/4 of an inch of soil. Remember that picture I showed you earlier. Go water someplace else. Go inside, watch your favorite TV show till the next commercial. Come back out, water another 15 minutes. The physics of water is the water in the soil will attract the new water that you've put on, and it'll add to the moisture in the soil. Soak and cycle is the way they suggest doing it. Irrigation and scheduling. Turf grass really needs to have deep watering, which is why we need about 6 inches of soil for any of our gardens, but especially turf grass, and deep watering. I see people watering at night with their hoses, and you're encouraging shallow roots. And those shallow roots, when it's 100 degrees outside, are just baking. You want that water in your well-amended soil to go all the way down 6 inches. Make those roots chase that water down 6 inches. In the top 1/4, when it's 100 degrees outside, that's going to dry out. 6 inches down, it's not drying out. It's staying moist. The water's still there. So irregular means once a week, once every 10 days. If you have well-amended soil, that's not an issue. If you have your typical clay soil, soak and cycle. And deep watering. Here's your Jeopardy answer for the day. Evapotranspiration. It's a made-up word. Evaporation and transpiration. Water evaporates from the land, from water, and from us in the form of perspiration. Plants transpire. So we call it evapotranspiration. And if you are a math geek, here is your formula. You get out your pencil, your paper, and your slide rule if you're old school, and you figure this thing out. The transevaporation calculator, and I'll show you one in a minute, takes into consideration the maximum temperature of any given day, the minimum outdoor temperature any given day, relative humidity, the solar radiation, the rainfall, and the wind. They put into a calculation, and it will tell you how much you need to water. And let's take a look at one. This is the website you need to look at, Texas ET, evapotranspiration.tamu.edu. And I'll show you more of this. This shows 2 weeks from June 1st to June the 14th. Just some real quick information, get this out of the way. June 1st, the evapotranspiration, don't worry about that, it's already figured out for you. They're telling us 0.23. Okay, it's 0.23. The maximum temperature is 86, the minimum temperature is 72, the relative humidity, you can read these. One thing you can notice as you look at this chart is the days of the hottest temperature, 95. Look at that solar radiation, 25. The days of the cooler temperatures, 90, 18. It's not exactly across, but it gives you an idea. The maximum temperature, there is some correlation with the solar radiation. And it tells you the minimum temperatures. Here's that wind I was talking about earlier. If you're watering at 4 o'clock in the morning on June the 14th, wind was 7 miles an hour. That blew your water all over the place. If you're watering at 4 o'clock in the afternoon, which is not what saws want you to do, on June the 1st, that wind was almost 8 miles an hour. This information is all plugged. Anyway, so this information, go here, and I'll show you how it works. This information is plugged into a calculator for us, and here we go. You can choose 3-day, 5-day, 7-day, or 2-week summary. The previous I showed you was 2 weeks. Are you doing landscape, or are you a farmer doing crops? Here is the landscape watering calculator. The evapotranspiration has already been figured out, 3.07. Plant coefficient, I'll tell you what that means in a minute. Adjustment factor, I'll tell you what that means in a minute. Effective rainfall, they figured it out, and they will calculate your watering required for you in that area. Not all sections of Texas are in this water calculation. Not all parts of San Antonio. We're just the north part of San Antonio. South part of San Antonio, it's just not on here, and I don't have an answer for you. You'll have to contact Texas A&M. So let's take a look at this. The evapotranspiration is already calculated. Plant coefficient, what is that? That means, are they warm season plants or cool season plants? Are you watering in the summer or is it March? That affects how much you need to water. Plant coefficient is also, do they need frequent watering? Do you have a yard full of coleus or natural rainfall? Do you have a yard full of succulents? That is your plant coefficient. And this particular one says natural rainfall. I'll show you that in a minute. The adjustment factor right here, maximum, minimum, whatever that is. Has it been 60 days of 100-degree heat, or has it really been pretty mild? Right now, if I did this, I'd be shooting for this. I did this back in June. It'd been pretty mild, and we'd had quite a bit of rain. So the effective rainfall here has already been calculated. And so my house, as of June 16th, the evapotranspiration was already figured out. The plant coefficient, I have pretty well native and well-adapted plants, so I want mine to be calculated at natural rainfall. They don't need a lot of water. My adjustment, it had been a pretty mild year so far, lower temperatures. We'd had 26 inches of rain. So I said, let's put the adjustment factor low at 0.5. They figured out the effective rainfall for me. So as of June 16th, how much watering do I need to do? None. In fact, really from January 1st to June 16th, I did not need to water my yard at all. And if you had well-amended soil, you did not need to water your yard at all for the first 6 months, 5 months and 16 days. You didn't need to do your watering at all. And that's the beauty of this calculator. How accurate is this? June 16th? Well, I decided to go find out. I put the soil tester into my front yard, and it says it is wet. So how accurate is this calculator? Well, it's pretty accurate. It said I did not need to water, and lo and behold, my soil tester says it's wet. It also says my pH is 6.8, and it says the soil temperature is 75. This soil is about 6 inches deep. So how accurate is the evapotranspiration calculator? It's really pretty accurate. If I can, I'll insert a video of how to use the evapotranspiration calculator. This is my sprinkler system. This is half-inch irrigation tubing. These are called T's because it forms the letter T. These are elbows because they call them elbows. Some people call them 90 degrees. This is the pre-drilled holes every 12 inches. And I have two of them. I have this one here and I have another one over here, and they connect it to one hose with a splitter. Remember that one diagram had a splitter? I use a splitter. These are 12 inches apart. This is well amended soil. So this water from each 12-inch emitter is going to provide moisture deep, and it is going to provide moisture across here, so that I can put this system on for 20 minutes if I want to, 10 minutes if I want to. This entire area will receive moisture. This is not subject to any of the water restrictions by saws because there is virtually no evaporation here. There's no water droplets, there's no sprays, no nothing. So this is the end of the second half of this part 2 of video. We need to rethink our water. First off, the awareness of the extent and the energy the saws goes into giving us good drinking water that we can wash and bathe in and use in our lawns and gardens. We really need to amend our current soil. If you live in San Antonio proper, you got the heavy clay soil, add compost. If you live north of San Antonio, outside 1604, build up your soil to at least 6 inches or grow everything in raised beds. Select plants that grow here that are water efficient, and plant them correctly. If they want full sun, give them full sun. Don't stick them underneath an oak tree. Collect rain in rain barrels and water your plants by hand, or devise or develop some sort of rain gardens. If you want more information about rain gardens, go to San Antonio Water System, type in rain gardens and see what they can give you, or go to Texas A&M University, see what they can tell you about that. If you at all can, and I know it costs money, but incorporate drip irrigation into your landscaping. If you want to do like me and build your own sprinkler system, or run the hose through your plants, that's really the best way. And be more aware of the sprinkler watering. We want those larger drops. The smaller drops, at a higher rate, or shooting farther away, they're just evaporating and we're wasting water. We need to be as water conscious as we can. So this is the end of the second video, and I hope that you got something from it. If I've said something incorrectly, please correct me. If you have any questions, you can send me an email saying you have some questions. But bcmg61@yahoo.com, and thank you for watching.